And rehabilitation, and in particular hand squeezing, needs several balls or grippers with different stiffnesses. Moreover, they need constant care from the physiotherapist to guide the patient's movements and make sure they do a complete squeeze. That is a way of hand rehabilitation that is boring and isn't playful. It's the reasons why we designed Menhir, which means mechatronic, easy and interactive rehabilitation. It's a mechatronic device with a trigger associated with several games to make the rehabilitation more ludic. This device allows adaptive stiffness. Furthermore, these tools provide direct feedback to the patient and record his or her performances for the physiotherapist. This is an advantage in an area without enough kinesiologists because patients can do their exercises at home.
As we said earlier, Menhir gives the patient a feeling of adaptative stiffness. This is due to the fact that we link the trigger to the servo motor thanks to a pinion rack system where the rack is attached to the trigger. The trigger is also bounded to the carter with a rail and slider to ensure a smooth translation movement for the user. There is also a small prismatic link between both parts of the trigger in order to push on the sensor. Thanks to the servo motor, Menhir can withstand strengths up to 45 kilos.
For the electronics, we choose two flexible force sensors to measure the force applied by the user on the trigger. These sensors are inaccurate for low values in their measuring interval. Thus, we decided to take one measuring strength in a range of 0 to 90 newtons and the other one from 0 to 200 newtons. For low values, the measures from the first one are used, and for values up to 80 newtons, we use the second one. This way they complement each other. Measurements are used to determine the position of the servo motor. Moreover, by saving them, we know if the stiffness for the patient needs to increase or decrease. To do computations, an Arduino card in serial communication with Python is utilized. And finally, the device has a diode LED on its top to warn the user that the trigger is at its apex position.
Now, for the user-friendly graphic interface, we created two games where the patient can escort the character, called EG, through different trials. The first game, Jump, is to make the patient train his or her endurance thanks to repetitions, making the turtle druid jump 35 times. The second one, Gauge, is to work on control, where the patient has to maintain the same strength for 30 seconds. What can be improved with Menhir? First and foremost, the sensors. We would like to replace them with a sensor test body to have a more precise measurement of the patient's strength. Secondly, we want to reduce the size of Menhir. It was not possible because of the size of the servo motor, but a smaller size would make it easier to use for everyone. With more time, we would develop more games and characters. Finally, we want to improve the design in order to make it more comfy and easier to set up. And we want to create a backup to follow the rehabilitation of multiple patients all at once.